Hey YouTube, I've gotten some questions in relation to how I kept the frame in alignment. Right now the frame on my 89 truck is in very good alignment, and I just put a new set of tires on the front. And the truck handles perfectly. What am I trying to say here? Oh, the steering wheel is exactly in line with where it's supposed to be horizontally. Now, in construction work, there's a term that's known as racking. So when you stud out a 2x4 wall, you measure from the diagonals, and the diagonals to the outside corner or wherever you're measuring to have to be exactly the same. And what that means is you have a right angle here then, and here, and all over actually, as long as you've used the same dimension of boards here and studs in between. So when you take that thought and you turn it into a car, what you basically have here is you have sort of something like this with a truck frame. On that order, something similar to that. And in order to get this thing racked, there's a couple different things you want to look at. First of all, if you look at my videos, you'll see that I pulled a string from the center of the radiator mount that was between the two frame members. I pulled a string, and when I pulled that string through, oh, it's a little crooked because I'm drawing it, I pulled a straight line through, and I had two other points that I could view and made sure that that was centered at that point. And what I did was I actually took an instrument, I took a surveyor's instrument, and I set up a transit, and I made a straight line, a line that passed through these two known points and extended out beyond here. And once they were extended out, from here and here is where I replaced the frame. This was able to be moved this way or that way according to this line. And that's how I, set that frame up. Now I knew the distance from here to here. I knew that distance because of when I started building the truck frame. I used the old frame, to give me that idea. So what this does is this straight line, as long as you have these dimensions what they're supposed to be, the truck is fairly straight. So now that's looking at it on a plan view. Now one of the other things you could do when you have the frame open is if you cut the frame at an exact point, like here in distance from another point, it could be from here back or from the front back, it doesn't matter where, but you want to cut the frame in 2 points, and then whenever you get a measurement from here, this end, to here, you want to maintain those measurements. You want them both to be the same throughout the building of the frame. So not only do I have this, which this line here that I gave myself actually was given to make sure that when the truck went down the road and the two front tires are like that the back tires were not facing in a different direction. I wanted to make sure that this axle was perpendicular or parallel. The wheels would be parallel to the front wheels. Okay? And that's what I have. I ended up with having, the tires and everything lining up so that I have a nice straight front end alignment when I did the wheel alignment on the truck. Now, some of the things that you need to realize is, you have three things. You have camber, caster, and toe-in. And toe-in is the amount of, and this is drastic, the amount that the front wheels, put the steering wheel here, that the front wheels toe in towards one another to keep them running straight. Now it's not as much as it shows there. It's like, I think I have a 1/4 to 3/8 of an inch toe in on the front of the wheel compared to the back of the wheel. That's the front wheels now, the front wheel. okay? And this ends up putting the steering wheel exactly horizontal the way it should be. The truck runs good. You could take your hands off the steering wheel of a 22-year-old truck and it'll stay driving straight down the road for you, even when you step on the brakes, because they're all new as well. And then, you know, if you're looking at the truck from the front, and let's say that this is the frame channel on each side. Now, the tires, when you draw the tires into place here, you end up with what's known as camber. And camber is the angle that the truck goes this direction. Now, on some vehicles, the caster and the camber is not adjustable, but anyway, the toe-in is because of the tie rod end. Well, we're going to talk about this camber for a second. The camber helps to keep the tire basically perpendicular to the road, although it is slightly out a little bit. But again, on some vehicles that's not adjustable. Now the caster would be if you had the frame of the truck. Okay, we're looking at the frame from the side, and it actually goes up in the air here for where the bed is. What you have is an alignment to the ground with the knuckles that are on the where the ball joints are, would be a certain angle to the road. Now what changes that is lifting or lowering the car. So years ago when I was a kid, we used to lift cars up by just putting long spring shackles on the spring perch where the rear end was. And what that would do is would raise the car up, and we would think that it looked cool and stuff. And there were a lot of theories behind what it did. But anyway, what it did was change the caster. Now, the caster on most cars today is not something you can change unless you do this. You raise the back of the car up. So if you raise the front and back the same distance, or lower the front and back the same distance, the caster remains the same. Okay, and that's a whole different ballgame with what purpose that would serve. However, what I'm talking about today is just getting the frame straightened out. So what I did was I put a straight line down through the middle from some known points, okay, and then I attached the frame, building the frame according to that center line. Put a C there for center line. And then I also would use these diagonals to make sure that the sections that I built were the exact same distance, whatever that was, okay. These were the same distances from one side to the other. And that's what kept this in such good alignment. So for the people that have asked me about this, and some of them have sent me emails, that's how I managed to keep the frame exactly straight. And I mean, at the most anywhere, we're talking 1/8 of an inch. But the center line was actually within the abilities of a total station line inside the actual instrument. I was right on. I mean, the thickness of a string or less is what you're talking about here as far as accuracy. And then what I did was, when I did a wheel alignment, I'll just draw two wheels in here. Let's imagine this is the front wheel, there's the back wheel. Looking at it from above, I set the total station up in such a way that I would come out here maybe 6 inches. And what I did was I actually set a bucket here with two tape measures, one on each end of the tire. And let's say at 6 inches, I would set myself up with the total station to be exactly in line with 6 inches out. What that allowed me to do then is to check the distance here and here. Okay, now you got to have the steering wheel horizontal when you're doing this to make sure that you're in the right spot that you should be in. And you only want to do one of these at a time. I mean, you don't want to do both of them, and actually you need two of these transits to do it, or total station. But the thing is I use this, which is a very expensive piece of equipment, and surveyors would know that. Even if you look up Total Station, and you'll know what I'm talking about. That gives me whatever I needed here. So let's say I had 6 inches here. I would want this to change and be 5 and 3. Let's see, I would want this 6 1/4 here and 5 3/4 maybe over at this end. Now, what this number here is would depend on, once you're straight, you want to line them up so they're even. You want to get even numbers, okay? You want to have 2 even numbers so that this is parallel to that one. It's in line with it. And then you'll go ahead and you'll figure out, you know, your distance, like your 1/4 of an inch or 3/8 of an inch difference that you want to be able to have your toe in, to bring the toe of the tire in. And that's how I did the wheel alignment. I took this and brought it on this side and did the same thing. Now the camber adjustment, I didn't do anything with the camber, and you can work, and the camber is adjustable on a Chevy truck. But I didn't do anything to it because the truck was always had good alignment before I started working on it. That's something that I was fussy about, because the road that I lived on was so bad that I used to get the alignment done every year just to make sure it was good. And the last time it was done, it was a very good job the guys did, and it stayed together nicely. So all I did was leave the camber the same. Even when I replaced the bushings, I still brought the camber back into the same measurement. So, you know, even though my videos show a lot of, you know, pretty rough and tumble cutting and welding and, you know, drilling, there was a lot of thought that had gone into this. In fact, I'll just show you, I don't know how good you can see this, but I actually have pages of drawings that showed how what the difference between the plain ground was and the profile of the frame itself. Remember, I had said there was an imaginary line going through there, and I worked off of that line. Now this is a plan view of the frame. You can't see the numbers, and I don't expect you to. I'm just saying that that's the trouble that I went to be able to make this thing happen. So anyway, I did get a lot of questions as to, you know, does the truck run straight, or is it, you know, trying to pass itself going down the road? And the answer to all those questions is that the truck is running very nice and straight because of how I did this work up in here. So, alright guys, thought you might just want to know that. I know there's a couple of you out there that have asked me. Thank you. Bye.